Imagine standing at a busy port. A colossal container ship, weighing over 200,000 tons and longer than 3 football fields, is gliding toward the dock. But this multi-million-dollar leviathan is nearly helpless right now. It can't steer precisely in tight spaces, and it certainly can't stop quickly. To park, it relies entirely on a tiny, almost comical-looking boat just a fraction of its size. The tugboat. It's the ultimate David and Goliath story, playing out every single day in harbors around the world. But how exactly does a boat the size of a house push around a ship the size of a skyscraper? How do tugboats move ships 100 times their size? Welcome to Simple Things Surprising Histories. Let's dive in. To understand this seemingly impossible feat, we first have to look at the physics of floating. If you tried to push a massive 100,000-ton steel box on land, you wouldn't stand a chance. Ground friction would defeat you instantly. But water is a completely different game. Thanks to the magic of buoyancy, the ocean is doing the heavy lifting. Because the giant ship is floating, the tugboat doesn't need to lift the weight of the vessel. It only needs to overcome its inertia in the drag of the water. According to the laws of physics, water offers very little resistance at low speeds. This means that even a small, steady force will eventually move a colossal object. The secret isn't speed, it's patience and continuous steady pressure. But don't let that fool you. These tiny boats are packing some serious hidden muscle. If you look inside a modern tugboat, you won't find much empty space. Beneath the deck, the hull is essentially one giant floating engine room. To put it in perspective, a standard family car might have around 200 horsepower. A modern tugboat? It boasts anywhere from 5,000 to over 10,000 horsepower. But horsepower isn't the whole story. Tugboats are built for pure torque. While a speedboat's propeller is designed to slice through the water rapidly, a tugboat uses massive deep-set propellers designed to grab huge volumes of water and aggressively shove it backward. In the maritime world, a tugboat's strength isn't measured by how fast it goes, but by something called bollard pull, which is the maximum pulling force it can exert on a stationary post on the dock. Modern tugs can generate over 80 tons of bollard pull, giving them the raw, undeniable grip needed to drag a metal giant. Yet raw power is utterly useless without control, and this brings us to the tugboat's greatest secret weapon. Traditional boats use a fixed propeller and a rudder to steer, but modern tugboats use an incredible piece of engineering called an azimuth thruster, often called a Z-drive. Instead of being fixed in one position, the entire propeller pod extends beneath the hull and can rotate a full 360 degrees. This means the tugboat can direct its massive thrust anywhere, instantly. It can push forward, pull backward, or even slide perfectly sideways. When several of these agile tugs surround a massive cargo ship, they act like synchronized swimmers. Communicating constantly with the ship's captain, they perform a delicate high-stakes ballet, nudging a skyscraper-sized vessel into its dock with absolute pinpoint accuracy. So, the next time you see a tiny tugboat bobbing in a harbor, don't underestimate it. Through the science of buoyancy, incredible mechanical torque, and 360-degree engineering, it is the unsung hero of global trade. Without these mighty little boats, the giant ships that supply our world simply couldn't function. If you enjoyed this surprising dive into the science of everyday things, hit that like button, share this video with a curious friend, and make sure to subscribe to Simple Things Surprising Histories for more. Thanks for watching, and I'll see you in the next one.